Hey everybody. Today we're going to be doing our first attempt at melting some gold out of the stuff that we've already pre-washed before using aqua regia. So it's going to be a mix of nitric acid as well as hydrochloric acid. Equipment here, we may not use all of it, but we've got our nitric acid, 70% nitric acid, as well as a big jug over here. You can probably see the shadow moving, but it's going to be 37% concentrated hydrochloric acid. So the way we have to measure this is in a 3-to-1 ratio. As you can see on the screen, there's 3 parts hydrochloric acid to 1 part nitric acid. So what we're going to do here, I'll probably have to stop talking for a little bit because I do have to mask up for some of this stuff. The acids do put off some fumes and stuff like that probably aren't the healthiest to breathe. So I'll be putting on a mask for it, and we'll get started. Okay. I don't know how well this is going to come through or not, but that's all right. I won't have to wear it for long. So we're going to do probably about it's off. Probably going to do about 100 milliliters total of liquid for the material in here. So this has all been through a nitric acid bath to recover some of the silver that was in it, as well as get rid of like elements of copper and stuff like that. As well as it's also gone through a hydrochloric acid bath in order to get rid of all the remaining base metals. So in theory, the remainder in this, and this is unique for the area that this ore came from, is going to be primarily gold and all the platinum metal groups, platinum, palladium, and rhodium. All that should be left might be some of the palladium and most of the rhodium, if not all of the rhodium. Some of the palladium might be oxidized in here, given the color, but it should take care of most of it. So, mask back on. And let's pour. So, we'll get another beaker here. Another beaker. Okay. We've got our 25 milliliters of nitric acid. And it doesn't have to be exact. So we've got our 25 milliliters of nitric acid. And now we're going to have to probably pour into another beaker for the 75 milliliters of hydrochloric. cap off. Okay. Those are 75 milliliters of hydrochloric acid. We may have to add a second batch if this isn't enough liquid. We have to stir this. I think it's safe to say that we may have to add more. Well, I see it working. I don't know. Got the acid. Oh, there. We've got the acid buttoned up, so bring this a little bit closer so that way you guys can see it. At this point, we do see a reaction happening. It is bubbling a little bit. Aqua regia does give off a heat, but it also puts off a few different noxious gases. As far as the gases go, why we have this in a fume hood, this can give off NOx, chlorine, and nitrosyl chloride, all stuff that we don't want to breathe. So, a little bit better light on that. I'm going to wash everything out with the white background. At this point, it is bubbling. We are seeing a reaction. So the end goal after this is going to be we filter out all the remaining solids. All the remaining solids should be pretty much rhodium, maybe some palladium. So all we got to do is wait for this to stop reacting, and then we'll be ready to go. Be ready to precipitate the gold. seeing as how this is our first batch, we're only doing a little bit right off the get-go. Um, we don't want to wind up throwing out a whole bunch of stuff if we wind up ruining the batch for some reason. But after the reaction stops happening, which this could be a couple of hours of this running, then we add this stuff. Sodium metabisulfite. So that will reconstitute the gold back into a solid in a pure form. So we'll have 99.999% pure gold is the gold. And then we'll see how much we get out of it. I am seeing a reaction here. You can see the buildup on the side. I don't know if that's going to show up too well on camera. It's looking a little bit fuzzy on camera by the looks of it, but at this point, all I have is a little wet. So the markers I'm looking for is this will drop out. The liquid that comes out will be kind of a gold color. It may be a different color based off of other metals that are in there, but primarily it's the reaction that we're seeing that we're looking for out of this. That means it's reacting with the metals in the acid, which that's good. A whole lot of metals in this that we're working with. If anybody has a source for a better camera, be sure and put a link in the chat. It would be nice to have a better camera so that way I can post some higher quality stuff. Getting reminded by several people, or told by a few people. Yeah, all right. Thanks, Jake. But I'm getting reminded, as far as some sort of disclaimer, that this is potentially dangerous stuff if you're not super careful. So I'm not going to tell anybody to not do this at home. I have done a lot of research on this, and I'm kind of learning as I go myself. So if people decide to venture into this, be sure and be really safe. You're as safe as you possibly can. Do the research. Like this whole fume hood, all this material back here, this is all lined with polypropylene sheets and all glued together. So polypropylene is an acid-resistant material. Obviously, I do have that hole in the back over there to run some cabling and stuff, but in this setup, I'm never going to work with enough acid to completely fill up the bottom of this. So I tend to stick to, or I plan on sticking to small amounts. And yeah, like I said, please do your research, people. This can be highly dangerous stuff if you're not super careful. And as far as the PPE, for people that are reminding me, I do have my chemical resistant gloves. And while I was working with the acid, I have my nice 3M cartridge mask. So now at this point, because I have a large enough exhaust fan, I do have a fan behind me that's helping push air towards the fume hood, just in case anything tries to escape. But I have a large enough exhaust fan up here that pulls a lot of air through it. So I've got plenty of airflow for it. So everything gets vented outside. But in this amount, it's not a dangerous volume. And at this point, that liquid, see if I can get a little bit more light on it. That liquid is very, very orange. So kind of a dirty orangish red color. When we go to do the filtration, when we pull the filter the liquid out from the solids, we'll just see how orange it can be. Because if anybody watched my previous stream where we did the nitric bath, that liquid was kind of a reddish brown. But once we filtered it, it came out super, super like emerald green. Then in the back behind me, I'm also continuing to roast more ore that we've crushed and filtered down to just the sulfides. Gotta swap it out here in about an hour. But the process at this point that I'm familiar with is we roast the ore first at about 1100 degrees Fahrenheit. Typically about 2 hours, but I tend to run it a little bit longer, 2.5. That burns off all the sulfides and mica and everything, gets it down to most of the metals. There may be some leftover sulfides, but it'll be just in trace amounts. After that, we do a nitric acid bath, which is 50% nitric acid, 50% distilled water, and that'll pull out some of the base metals like silver, copper, some iron that isn't oxidized, and stuff like that, which the roasting should get rid of a lot of the oxidation. Then we give it a water bath with distilled water, boiling distilled water. We do a couple rounds of that, let it boil for an hour or two at a time, rewash it a couple of times. Then after that, we do a hydrochloric bath, which is about 15% strength hydrochloric acid. And that'll remove the remaining of the base metals. After that, we're left with just the noble metals, or we should be left with just the noble metals. That's going through that. Rather than just sit here and stare at a bubbling beaker for a while, because that ain't going to change. We'll come over here. Excuse the mess. Show you guys some of the material, what it looks like at varying stages. So these over here, this is the sulfides that haven't been roasted yet. You can see it's a pretty dingy brown color. There is a fair bit of oxidation in here that happens from the water as it runs through a shaker table. After that, kind of set up something here so people can see the differences. Get a chunk of that. So you can see kind of the difference there. So there's some of the base material before roasting. And then here's the material after it's roasted. So you can see some dark colors, some deep reds and stuff like that. There's still oxidation here, so you can see that there's some of that. So you can see the color difference. It's a lot more red than the non-roasted material. Then at that point, once those two stages are done, then we have the stuff that has gone through. I don't have any samples actually of the stuff that's been through just the nitric bath. It's very similar to this material, which is kind of a deep purple, purplish red color. And this is the stuff that we plan on sending through the aqua regia to try and extract the gold, as well as the rhodium later on, which that'll be in a later stream. So now you can see the differences. I would put some on here, but I don't want to waste it because this is all what should be theoretically all the really valuable stuff. So you can just kind of see the difference in color here. It loses a lot of the redness and looks kind of a dingy brown purplish color between them. Then throughout the process, I try to document everything. We've got a roasting log, nitric bath log, hydrochloric bath log, and we've got a new one started for aqua regia. So we'll be logging everything as much as we can so we know what we have versus what we lost as far as weight goes. We roast the material in just these little ceramic crucibles, which I do have several of them here. We'll eventually be melting stuff in some of these crucibles, which is why I have some that are dirtier than others. I use some of these larger ones for just roasting more material. I have the biggest one in this in the kiln here roasting. You can see that running at 593 Celsius. So, but we just use the little, I just use this little holder pocket scale. Works good. It can measure stuff in, once it boots up, grams, ounces, troy ounces, dry weight, carat, grain. But I typically measure everything by grams. I guess with that being said, we'll move back to this. Watching it. Looks like it's still bubbling. I don't think I can get that any closer. Why what? It's a little bit finer measurement rather than go by pure troy ounce. A little bit easier to measure smaller amounts. Not grains. I don't measure grains. I measure in grams. Go ahead and give this another stir. Everything I've read or looked at with other videos says we should stir this occasionally. You can speed it up with heat, but I didn't want to add heat yet. It does look like there's a yellow film up on the edge. Not sure what that would be from. All the other processes, yellow should indicate a amount of iron being melted in the acid. Just going to get a small flask or a small beaker of distilled water just for a safe space to put that. We wait. About 49, 50 minutes, we'll probably move over to the kiln again, because it'll be time to swap out. Why don't we do that? Let's prepare another batch of ore to get ready to swap out in the smelter. Or in the kiln, sorry. By all means, if anybody has any questions, feel free to ask. I may not get to them immediately, because there are some stages that I kind of need to be focused on, but I will definitely get to them. So with this, always beforehand, we measure out, or we find the weight of the crucible. It looks like 100 grams even, so we're going to zero that out. We'll probably just spoon in a little bit of material. Squish it down so we can get more in there. I do 2 crucibles so that way I can have one cooling at the same time as we have one cooking. So looks like this one's going to be 87.1 grams of material. Okay, so that one's ready to go. Turn that back off. Put the lid on that lightly. So you can see on this one, I've got 178.4 grams in there right now as dry weight or as pre-cooked weight. And we do see a significant loss in weight after roasting. Some of that may be water. There may be some residual water in this material, but definitely a significant loss. Like you can see on the last batch, it was 177.5 grams. After roasting, it was 160.9. And this just shows the total that I've done so far. I've done 1,978.4 grams. So the material, so this material, to answer your question, Jay, this material here contains everything. Um, a The nitric bath is what pulls out the silver. Now, I don't know. I don't know how well this is going to show up, but this is the results after one bath of nitric acid. If you can see the little bits of powder in the bottom, that is the silver nitrate. Obviously, that's not very much. In this bowl, I'm leaving it kind of just soak in distilled water just to save it for later. Once I have enough, then I will precipitate the silver out completely. But I have to have enough to work with. That process, set this off to the side so I don't spill it. That process involves sodium hydroxide and dextrose. So the sodium hydroxide is just a powder, nothing dangerous about it. Basically just lye. And then the dextrose, this is just essentially very pure sugar. And it's the same thing. It's just a very fine powder. And we'll use that when we go to precipitate the silver out. But like I said, because we're not getting a lot of silver, this material doesn't have a lot of silver in it. It's going to be a while. One other thing we will need to do, once we finish this step of aqua regia, is we'll have to add pure tin to hydrochloric acid to make our own stannous chloride. So this is just a bag of pure tin pellets. We'll add some to stannous chloride. It's about 1 gram per 15 milliliters of hydrochloric acid to make stannous chloride, and we use that to test the material. Once we get the liquid, we start adding the SMB to the liquid, and as we add it to it, we can continue to test the liquid with the stannous test to see if there's still gold in the liquid. See something else here? No, that wasn't the same beaker. So the stuff that was in the beaker is the stuff that already ran through the hydrochloric acid bath, this material. So the stuff in the beaker is the stuff that I've already done the beginning several steps of the process. It's been roasted, it's been through the nitric bath, it's been through the hydrochloric bath, and now it's all this stuff here, including what's in the beaker, is for aqua regia. So I do have a couple of droppers coming for this stannous chloride that we have to make, as well as some test strips, but that can be easy enough to test with just a little bit of the solution on a paper towel. So when we get to that stage, we'll probably go through the process of making the stannous chloride. I don't want to make it yet because it does lose its potency after a little while. Looking at this, it does looked like it stopped reacting, or it's not doing anything at the moment. Give it another stir here real quick. It doesn't seem to be reacting. They let that sit for quite a while longer, though, just to be sure. I want to be sure that we melt everything out of it so we get the best bang for our buck as far as the gold is concerned. And that's the main thing we want out of this is the gold. I still do see a fair bit of solids at the bottom, but not nearly as much. So that's a good sign. That is a pretty yellow color coming in up off the stir stick. I think the next batch we do, if we successfully do this, we're going to probably step it up to a little bit more than 50 grams. I think this is like 54 grams. And sorry, I'm not 100 grams. This was 50 grams because I was worried about the amount of reaction and making sure I had enough head space in the beaker, enough empty space in the beaker to hold the material. But it doesn't look like it's as violent a reaction as like the nitric acid bath. The nitric can bubble pretty hard, especially in this material with as much copper and stuff as we're getting out. So this may be done fairly soon. At that point, then we use the handy dandy filter flask. We'll have this with a vacuum line. Actually, this vacuum line here, this line hooked up to it, and a filter, a funnel with a filter on top. It's called, probably going to kill the pronunciation, but a Bushner funnel. But essentially, just a funnel. This is the Bushner funnel. It's a funnel with a bunch of little holes in it. You put a filter in this, and it'll keep all the solids, which are the important solids, because the remaining solids should be rhodium. It'll keep it from getting sucked down into the liquid. And it's just a simple little vacuum pump that's going to be hooked up to the end on the filter flask. I see absolutely nothing reacting with that. So I think at this point, I think we should probably hook up the filter flask and see what we get. And maybe we can do a little bit larger amount all in the same stream. Seeing as how it's not that reactive. I think so. I think that's what we're going to do. So I'm going to scoot you guys over here just a little bit. Give myself some room with some gloves. And we'll start the process of filtering this stuff out, and we'll see what we get. Try to give you guys a good view of that. Again, these filters, I know I showed it last time, but these are the filters, binderless microfibers. So these types of filters are resistant to the acids. Like if somebody decides to do this on their own, one of the things you want to be sure of is there's a lot of these types of filters online that are made of cellulose. Cellulose will break down in these acids, so at that point, your filter would just melt in the material. But seeing as how these are binderless, they stand up to both the hydrochloric and the nitric acid. And unfortunately, my Bushner funnel is 80 millimeters. These are 90 millimeter filters, so I have to kind of cone them in a little bit just to keep them from anything happening. I don't know if the vacuum pump is going to come up over audio. If it does, I hope it's not too loud. But yeah, it does sound like it's coming up over the thing a little bit. So now I should be able to pour out the liquid carefully. That is a pretty gold color. There's what we're left with for the solids. So it's pretty dark looking stuff, but it's still that muddy reddish color. It's going to show up on camera. It does look like there's still a little bit of liquid left. So we'll kick that back on. We have to let that drain for just a little bit. I don't think we're going to get much more liquid out of that. That orange color is what we're looking for, or what we're supposed to be looking for, from my understanding. So I think we're doing stuff correctly here. I think we're doing stuff correctly, I'm going to say. So now you can see from that, you can see the solids, some of the solids that passed through, that got stuck in the filter. It's pretty dark looking stuff. But that's all just a really fine silt. So I think what we'll do is we will dispose of the filter. And we will probably put this, just to ensure we don't contaminate anything or get acid on something. I do have a distilled water bath that I'm going to drop that into the filter funnel. And now we can put this into a beaker. Matter of fact, I think I need to wash one of these beakers. I would have a second large beaker, but I accidentally broke one today. Because I'm smart like that. Correct. Yeah. So this orange liquid here, this is the golden suspension. So all we have to do is transfer this. Once I get this dried here, I've got this little flat beaker here. Then I'm going to add this. I'm going to pour this liquid out of this flask into this beaker, and then we should be able to add in some SMB to precipitate the gold out. So, be just a moment while I dry this off. Okay, now we have a clean flask. Back on, since we're going to be handling beakers that either did have acid or still have acid in them. I'm going to bring this up to the front here. That way we can see in it. And we will pour our solution into this. Wow, that is orange. Color that beaker now, or that flask. And it's yellow, yellow. Okay. Then we will give that a bath here real quick. Spilled a drop on my hot plate, which I guess doesn't really matter with as much gunk as I already have all over the hot plate. I don't want free acid just sitting outside of it. So, okay, now the SMB. It's an unknown amount that we're going to use because we don't know how much gold is in the material. So, grab our bucket here. Still got the seal on it. Flip that off here a little bit. Okay, then we have our highly scientific measuring spoon, aka just a spoon I got from Walmart. It's a box of plastic spoons. And now we're going to slowly add our SMB to the mix. It's got a pretty interesting reaction to it. I do see a gas vapor coming off that, so again, be sure and be safe while you're adding this stuff. In theory, I don't know if that's going to show up at all. I don't know how much SMB we're going to have to add to this. Get a flashlight, see if we can see any at the bottom. I can't tell if that's just murky or if there's any solids in the bottom there. Oh no, there's solids. I see it. In theory, that should be the gold, guys. So we'll keep on adding. Obviously, you want to add this stuff slow because that's a pretty violent reaction. Yeah, we do have some solids in the bottom. There's some fine powder in the bottom. I think next go around we should use a bigger beaker for this. I do have them on order. I've got a couple of 2-liter beakers as well as a 3-liter beaker coming. So we can do larger jobs as well as be able to move stuff back and forth. See some solids precipitating in the bottom. But I think it's time to set up the stannous chloride. So we'll need that anyways, just to be sure that we can test material. So we're going to take this small beaker, dump that out, we'll dry it. We'll have to figure out what to do with these solids afterwards. We'll save these solids for later because in theory that should be, if that's rhodium, that's a lot of rhodium, guys. Like a lot of rhodium. But you can see that in the bottom. I don't know if that's all solids yet at this point. I really want to be hopeful and say that's all solids, but we'll find out here in just a minute. Dry off this beaker. Quick distilled water bath. There sure does seem to be a lot at the bottom of that. It's definitely got a dividing line. Yes, the final result will be almost a sand, really fine sand. Should just be tiny, tiny grains. There'll be a little bit of prep here. I am going to put on my mask since hydrochloric acid emits some pretty nasty vapors.
There we go. I don't know if you guys can hear me or not still, or if it makes any sense with what I'm saying, but mask on. And seeing as how we need just a little bit of acid, I'm going to use a granulated cylinder with a pipette. So I'm just going to drawing material from the container with a pipe end. Just about there. All right, there's our 15 milliliters of hydrochloric acid. We're going to get the cap back on here so we don't get these fumes. Get the mask off here.
Okay. So now we have our acid. Now we add the acid to this beaker here. Then we need to weigh out our tin. Move back over here to the kiln. We'll just go ahead and use one of these. From what I understand, it's about 1 gram of tin per 15 milliliters of acid, roughly. Oh, get some tweezers around here somewhere. Probably gonna have to be a bit. 0.4. One gram. Okay. See that back up. So we've got our 1 gram of tin. Put the gloves back on. Drop our tin into that. Let that melt for a moment. In the meantime, I'm going to cut up some strips of paper towel so we can use that as just a test. we're doing here is building a. That way, we need to know if we need to. That way, we know if we need to add more SMB or not. What we can do is rest it directly on the polypropylene sheet. Won't hurt nothing. The polypropylene is resistant to acid. So I don't know if those are melting. We need to take a little bit to melt. Well, it is melting a little bit. It's kind of a very faint yellow color. So it is melting the tin slowly. We may have to add more acid to it. I think while we wait for that, I'm just going to give this a bath real quick. Set this over here to dry. And melt. Hindsight, maybe I should crush up this tin. Supposed to be getting a mortar and pestle tomorrow. That way, maybe I can just crush up the rest of that tin to a powder. Maybe that'll just speed up the process, increase the surface area of that. Because as it stands, I don't think we will have in a reaction. I don't think it's dissolved enough. At least I highly doubt it. So we'll grab a pipette here. We use the longer one to grab out of this. We'll grab just a bit out of this. Drip just a bit on there. And then in theory, should be able to take this if we drip it on there. Yeah, I don't think it's diluted enough in the hydrochloric yet. That may take a little bit, seeing as how it's whole pieces. So, we just a moment. Maybe able to speed that up a little bit, actually. Set that there. We'll turn on the heat a little bit. Well, we went by the measurements, so there probably won't be anything left of the tin. So you might be able to reuse it, you might not. I highly doubt it because it would still be soaked in hydrochloric, so it may just slowly erode over time. Grab our handy dandy magnet, drop it in there, stir it and heat it at the same time. That's really curious. I'm just going to take the towel out of here. It does look like they're changing colors just a little bit. We don't want that splashing around. Turn up the heat on it a little bit. Get that reaction going a little bit faster. Getting yelled at for not using PPE, and he is right. I should really be using gloves. It does look like it's turning more of a yellow color. Got about 7 minutes left on the floor roasting in the kiln. So what we may do is we may leave that to melt. I'll wait for this. Probably add some get this scooted over out of the way a little bit. This is our valuable stuff. This is more valuable stuff. I think what we'll do is we will begin the wash with this in distilled water. So we'll leave that to sit. I don't know if that's going to show up at all, but you can see that stuff in the bottom. That should, in theory, be our solids at the bottom. We just need for this stannous test to finish. Finish dissolving the tin so we can perform a stannous test. Looks like we've got about 5 minutes, so we'll move over here back to the kiln. And a good place there that'll work. Back you guys up just a little, so you can see everything happening. And again, this part isn't involving acids so much, but obviously hot stuff is dangerous too, so always be sure to use protective gear. So in this process, all we're going to be doing is pulling the crucible that's in here out and putting this one in, and then we'll let that other crucible sit here and cool. It's been sitting in 1,000 degrees for a couple of hours, so we don't want to rest it on the scale because that'll probably just break the scale immediately. So we'll just wait for a few moments. Got about 3 minutes. While we're waiting for that timer to be done, we'll go back to the stannous test for a little bit. You see that stuff is getting pretty orange. It's letting off some vapors as well. It's probably from the hydrochloric and the heat. Okay. Now we'll take this out. We'll just leave the kiln running. Nice and careful. And we reset our timer. So we'll let that one cool. But as you can see, pretty dark stuff. As it cools, it'll turn more of a red color. Okay. Come back on with the gloves. Let's see here. This should be pretty warm. I think we're going to set it down over this fabric. And we need to open it out. That out of the way. Put that in there. Just keep it weighed down. Otherwise, the vent hood might suck it up into it. Let's see. So we use this longer one for this test. No. We used it for this. Shorter one for the stannous chloride. Maybe we need to add more stannous chloride or more SMB. Tell you what, why don't we do that? Get that out of here. Get this set off to the side for the moment. Set it back there. And we'll add some more SMB. If we can get more precipitation out of it. That fogged up pretty quick. It does look like solids in the bottom to me. It actually shows up on the camera as well. Should be able to see that line just right at the bottom here. I don't know what's going on with this. I would really like to test it. Maybe we need to redo it. I can't crush up those pellets that are in it now because they're covered in hydrochloric acid. Don't think there's enough surface area to melt it there. Stick water in this. That off to the side for now. It's interesting. Not sure how we're going to do this. Wonder if I get some new tin. Maybe try to crush it with a pair of pliers or something. Get it crushed down into small pieces. I think we'll smash some new tin rather than reuse that. If anything, to at least give it a little bit more surface area and maybe create some little tiny fractures or something like that. Why don't we'll just leave that there for a minute and we'll use a fresh beaker over here. Ooh, you can see that turning red. That's pretty cool. So yeah, I think we'll use some fresh tin. Okay, 1 gram. Now, get a fresh, clean beaker. Guess maybe a pair of pliers. Move this out of the way a little bit. That stuff is pretty foul. Smells funky. Drop it. That might do it. It is pretty soft stuff. Get a pair of pliers here. something with a little bit more flatness to it. And I just lost that one. I think next time around, excuse me, I will order some, rather than tin pellets, because I figured being pellets, they would have melted pretty quick, but I think I'll just get some powdered tin next time, and that'll probably do a better job. I dropped that. These things are so darn small. Hard to get my feet hooks on them. One more. Okay. So now we have our crushed tin. That should make it at least a little bit easier, a little bit more surface area. Come back here to this. We'll just add some. This is just distilled water in a spray bottle. Just fill that up with some distilled water, set that off to the side just to make sure that it's really diluted. And that means we need more hydrochloric. Time to get a mask again.
Okay. That's about there. Okay. That's out my pipe out. Okay. Got back on the hydrochloric bath.
Mask off. Let's try it again. And that turns pretty yellow almost instantly. Seem to be reacting. Give them a minute. The interesting part is this reaction actually produces hydrogen bonds. Neat. I don't know why we weren't doing it in the first place, but why don't we just use filter paper, seeing as how the acid won't melt it. So we'll use filter paper for the stannous test. Now we might have gotten all the gold out of it. We don't know. Because realistically, the way it should work is if this material here, this liquid, you put a spot on your test plate or whatever, and then you put a drop of the stannous chloride on there. If it turns black, there's still gold in it. So it hasn't been turning black or dark purple or whatever color you want to call it. So maybe we got out all the gold. I don't know. Realistically, in hindsight, we probably should have pre-made the stannous test. We didn't know it was going to take this long to create the stannous test. To test the liquid before adding SMB to it. But hey, this is why we do small batches to start with, so we learn while we're doing it. There is definitely a definitive line of stuff in that beaker. What that is at this point, I don't know. I guess we'll wait for just a moment. Bear with me. Remember, if you guys have questions or anything, feel free to ask them in the chat. Tell you what, while we're waiting, we'll be right back. little bit of cleanup real quick. Got rid of some of the excess stuff in here, letting the beakers that held the acid just neutralize those and cleaned them out. Getting them soaking in a distilled water bath. So, suppose what we'll do now is we'll go ahead and try the test again. Got our pipettes here. Suck up just a little bit of that. Scoot you guys over here just a little bit. Just a dab on there. Then we'll try our status test. Doesn't appear to be changing any colors at all. So I think what we'll do, just seeing as how this is a test batch and it's relatively small, we'll probably filter out the liquid from the solids out of this, and we'll see what we're left over. So I will grab a clean beaker, and we'll just transfer the liquid from one to the other. Dry it off real quick. So happy when my still gets here on Monday. I could make distilled water myself, just basically boiling water and stuff, but if I have a dedicated way to do it rather than hogging up the stove in the house or something like that to make distilled water room stuff, I'd rather just use something dedicated to do it. Has many other applications though. Because, you know, it is a still. Okay. Suppose if this filter valves on, get that rinsed out. This one rinsed out. We'll go ahead and transfer our liquid. Just scoot it out of the way a little bit. Pour nice and slow so we don't wind up dumping the solids into there. Because in theory, the solids at the bottom should be gold. That almost seems cloudy. But man, that is very gold colored. Okay, so I think what we'll do now, I think we'll introduce some distilled water. I'm really not sure. Very yellow at the very bottom, but I'm not sure if that's gold or if that's just the solution. Regardless, we're holding on to the liquid. It's interesting. It's like it was all just murky water or murky solution. I don't know. Very curious. I'm really not sure. I wonder what it'll do if we put some more SMB in there. If it will react, even though we added distilled water. SMB. Still react. Oh yeah, that definitely reacts a lot. It's really strange. Oh, man, that got really dark. That reacts pretty crazily. Floating chunk of SMB right there. Everything I've seen, it seems to be the right color. I need to reread some things. We didn't add enough water, distilled water, to dilute it. Obviously, since it's still reacting. Very, very yellow now. Not sure. So what I think I'm going to do, guys, is I'm going to let this sit probably for a good few hours and see if anything precipitates out of the bottom again. Maybe it has to sit for a while before it actually pulls something. So thermic reaction doesn't feel hot. It's kind of like a mustard yellow color. I think that's what we'll do. I think we'll leave it sit. See what happens. Besides, we gotta let that, apparently the stannous chloride solution apparently dissolve a bit more. It is slowly turning more and more yellow, but I don't know what it's doing at this point. And I already do see a little bit of separation on that higher up on the wall of the beaker. I don't know. We'll leave it sit. See if it does anything. But at this point, it didn't seem like there was a lot of solids in that. And what that means, I don't know. But we will find out. In the meantime, I guess we will continue roasting stuff and preparing more material. We'll go from there. If anybody has any questions further, feel free to leave them in the chat. I will probably be sure to update on the video what happens if anybody else happens to be watching this. But we'll go from there. Definitely add something into the comments on the video once it renders and as to the outcome of it. I guess for now, everyone have a good rest of your evening, and will see everyone soon. Thanks again to everybody for taking a look at stuff. Any questions, comments? And talk to you later.